Hello, welcome back to Stunning Science page. So very good evening and I hope all you are doing great. Today's topic, is very interesting, just like the topic we had discussed yesterday, right? So yesterday we had discussed about projectile motion. So there are many important things that which equation the student should consider, right? Projectile motion, right? So yeah. So but here today there is another important concept that some of our students actually messaged me, sir, how actually we should go about that. So also the related numerical. But today first we'll learn the concept, right? It is refraction and dispersion of light through prism. Okay, yeah. So we'll just wait for 1 minute and let's see how actually the students are coming and the audience. So we really want your engagement. Just a second. So the main important thing is that refraction and dispersion through prism. So that is very common, right? But in nature, in atmosphere, it is something different. So for example, the rainbow formation, right? So how we can see the beautiful majestic rainbow in the sky, right? But normally it happens after the rain, right? But now the thing is that the concept is that so light is getting split into its constituent colors and lots of colors. So the 7 colors is producing, and right? And from the lower class we have learned about the Vibgyor. So the V stands for the violet and the red R stands for the red, right? Vibgyor is the spectrum band. So we have given the name in physics. But here there's a concept that we are going to discuss today. It is how light behaves when it is going inside the water droplet. So for example, suppose there is water droplet, right? Water droplet. How actually light goes and what is the nature? How actually does it behave? So only the refraction is happening, or the dispersion happening, or the total internal reflection, or the partial internal reflection is happening, right? This is our agenda. Let's see how actually it happens. For example, I'm just drawing a spherical droplet. So water droplet I'm drawing. This is my water droplet, and we know it is naturally it is a spherical, right? We can say it's a sphere, it's a circle, spherical water droplet. So it is happening in the nature, right? So now light rays is coming, light rays from the sun or the any light source is coming. So it is passing through the droplet, correct? So light ray enters. Okay, so the refraction is happening here because this is W, water, and this is air. This concept is very simple, it is clear, right? So whenever there are two mediums involved, air and water, so because of the two mediums, the bending of light will be taking place. So the refraction will be happening. Now the thing is that it will bend here like this, right? After that, what would happen? So it is one of the biggest questions. So many students are getting confused here. So what would happen after that? So clearly it should go like this, right? Because this is air medium, this is air, this is water medium, this is also air medium. So now here light is getting dispersed. So the dispersion of light happening inside the water or the water drop. Let's see like this. Okay, so this is actually the band of colors, right? So I can write spectrum. Okay. After that, the interesting thing happens. So as now, see, we have considered it's a spherical drop. So now we need to consider it is the center of the spherical drop. Clear? It is the center of the spherical drop. Then if I draw any line from the center to here, because light is incident here at the air water interface, so it will be like just like this. It becomes normal, right? So this is your incident ray, incident angle, angle of incidence. This is incident ray, and this is angle of refraction, right? This is angle of refraction, this is angle of refraction. Okay? So now see, there is another concept. Let us see this way. This way I'm just I'm marking in let's say in red pencil or marker. See, this way ray 1 I'm taking. Now let's consider it is just going back. It is coming from the denser medium, okay, water medium. So if it goes like this, then definitely it will be passing like this, because in rarer medium it will go away from the normal. Now the interesting thing is happening. But if we don't allow to exit through in air medium, so if I want to allow, if this ray is going back, is coming back inside the water medium, then it must be greater than the critical angle of the water medium, right? So it must be greater than the critical angle, you have to remember. Okay? So then oppositely what is happening? So if it is a critical angle, if it is the less than critical angle, then here also I am now drawing from the center. Here also I am just making a normal. This should be also the angle of refraction, because geometrically this angle and this angle would be same. So it must be lower than the critical angle. Then what should happen? If it is lower than the critical angle, then partial internal reflection will take place. Clear? So total internal reflection is not happening. Here total internal reflection is not happening. Be very clear. If the condition for the total internal reflection, it should be the angle should be greater than the critical angle. Okay? But here from the concept of geometry we have seen, so we have done some back work, right? Back process. So here it is less than critical angle, right? So obviously this angle should be less than critical angle, right? If it is less than critical angle, so some part of the light rays will be traveling, okay, so will be emerging from the water drop, and some part of the water droplet will come back, that is partial internal reflection is happening. Partial internal reflection is happening and it is falling on the next surface of the water droplet. So opposite side of the water droplet, correct, inside it. Now then again I am drawing a normal here. So it is emerging like this. So similarly like this it is happening. Here also I am drawing normal. Okay, it is happening. Clear? So inside the water droplet, partial internal reflection is taking place, not total internal reflection. In a couple of textbooks, you might be, observing that total internal reflection is written, right? But somehow it is not total internal reflection, it is partial internal reflection, because it must be lower than the critical angle. and that is our main concept. So here dispersion is happening, refraction is happening, partial, total, not total, partial internal reflection is happening, and it emerging. So simply bead gear, so VIV GYOR, right? And it is a very simple concept that the violet actually, so it has a very small wavelength, right? So it is bending much than compared to red light, right? So at the top it should be red and here it should be violet. So the ray which is bending at the maximum level or maximum value, it is actually violet. So now after that it is just like it is just emerging, right? So it is coming from the arc of a spherical drop, right? That is why we can see it's a beautiful arc in the sky, that is called rainbow. Okay, rarely we have seen the straight rainbow, right? It's very impossible almost. So because the water droplet should be there in the atmosphere, so as they are emerging from the surface of the water droplet, and we have considered, and not we have considered, but the water droplet is spherical in nature. So this arc, from this arc they are emerging. So it is like it's just like an arc. It's a beautiful arc is getting produced in the air, that we call rainbow.